Welcome everyone. I started recording, so as you know as well. Okay. So this workshop will be about Instance Noodles, as you can see there, and our guest star is Everyoneishappy, and its real name is Kyle McLean, and he's currently streaming from. Where are you precisely, Kyle?
Secret location.
Secret location, okay, but that secret location is actually 10 hours ahead of us. So he's such a hero that
from the future.
Yeah, he's from the future. He's such a hero that he woke up at 7:30. Yeah, am I right? He was
on a Sunday morning, man. Yeah, after quite a late night.
Yes, it's like you are a hero, mate. And he will show us his very mental packs. Not packs, just a single pack. The Instance Noodles, which is actually being used right in this demo as well, around this kind of waving thingy, and actually these splines are using the with these splines from Instance Noodles too. So that is a very useful tool. And if you are ready, Kyle, I can switch to your desktop right away.
Sure.
Okay, just a second, because I wasn't ready enough. So there you go. The show is starting.
Okay. Well, hey everyone. Yeah, as David said, just gonna go through Instance Noodles a bit. For the most part, we'll actually just be going off some of the girl power and the help patch stuff. So like, if you want to follow along, if you've got Instance Noodles installed, you should have all of those already. Later on, if we have time, we might look at creating some new stuff, and any materials that we make, I'll put like in a Dropbox folder or something. So yeah, you'll have to bear with me. I haven't had heaps of sleep, so I'll make some coffee noises. For the start, if we just I'm just gonna assume people have Instance Noodles installed already if they're doing this workshop. But otherwise, if you grab it from the contributions page and just put it in packs in your 4v folder. I'm using pretty much mostly.
Well, just a second. There's a question there. Do you have a GitHub?
Yeah.
Or is it open source?
I'll talk about that later on. Yeah. Yes, and yes.
Oh, nice. Very nice. Because I always wanted to ask that. I never discovered it. Yeah, go on.
Yeah. I'm not sure if my chat window's actually picking up any. Might need to restart it or something.
No, it's picking up. Oh, it's it's
there we go.
Up. There you go. Yeah.
Yeah, working. Sweet. Okay. So yeah, I'll just there's some Git stuff. I'll post the link to that later. So Instance Noodles. Hey bro, how you doing? We've been joined by the panda. So yeah, in a nutshell, Instance Noodles is just like a modular library for using geometry shaders and compute shaders in DirectX 11 and 4v. So if it's not already apparent, you need the DirectX 11 pack installed as well as the Instance Noodles pack. I'm just gonna open 4v up in the background and we can have a look at what's actually in there. So roughly speaking, it's got a few shaders and things, but for the most part, Instance Noodles is not really concerned with rendering at all. we're more just looking at doing stuff with geometry, and there are some compute shader things there as well, which can be used more generally, but we'll get a little bit more into that after we look at the geometry stuff. So in general, it's basically hang on, let me just get this other window here. I'm just if you go in the grow power, and don't know if you can see that all right. Yeah, in geometry effects, and this is just the first one. Don't mind this background grid. I think the module's broken at the moment. It'll come back. There's this one from MicroD there. So yeah, essentially the kind of idea with this originally was it was just going to be geometry shaders actually, and I liked the way with texture effects in 4V that it was really modular, so that you can just chain them. You can have source nodes and filter nodes basically, and so this was working with the same idea. If we look up the top here, we can have any geometry going in, and then we have one or more geometry effects nodes on it, and then at the end here the geometry is coming out, and what's coming out there doesn't actually, it's nothing special. So the nodes downstream from that don't actually have to know what's going on here. They just get a normal piece of geometry. So we can also change the input there, obviously. Let's say like a torus or something. You can see we'll have the same effect going on, just with different geometry. So what's actually coming in here can be anything. It can be one of these native nodes. It can be a model you load through Asimp. The kind of, there's some crazy nodes for whole and stuff, but I think just geometry file. That's kind of your basic if you just want to load a mesh. And then there's a couple nodes as well which are generating it inside a shader. We'll have a look at that as well. So if I bring up a, oops, sorry. Just gonna bring up a patch inspector. So if put in noodles, you can see there's a fair few there. There's like 140 nodes coming up. Most of those are actually compute ones, which we'll look at in a bit. But then we've got a few of these. So these basically, if you type something like that, then you'll get a idea of which ones you can use. And it's very much similar to texture effects, in the sense that we can chain these together. If you turn one off, you're basically just you're just disabling that, so it's just going to pass through whatever is coming. Same as the texture effects. So if I turn this one off as well, we can see that's just the pure geometry. Yeah. So some of them are really simple. Some of them have a few more controls on them. Just in general, there's a little bit of a difference in behavior when you're using geometry effects in terms of 4V and spreads, and basically in a nutshell you can say it like this: the geometry shaders, and actually the compute shaders as well, are not spreadable in the traditional sort of 4V sense. So for example, if I had several geometries, I wanted to cons them together, so let's take our torus and our sphere. So if I just pass that straight to a shader, we're spreading the shader. Yeah, I've got two geometries there, you can see here. If you try to pass that through geometry effect, you'll see it's actually just taking the first one. So that's kind of just something to be aware of, is that they're not spreadable. We can use buffers, so structured buffers are basically just like spreads for the GPU. And that can be used for things like, on this noise one, for example, we can actually control the noise level with a buffer instead of a single value. In terms of geometry, there's a node for doing that if you need to basically take multiple subsets and turn them into just one mesh. So you'll see like a lot of the nodes, they'll have like for example, it'll have some type of perimeter. Like here we've got if you notice, by the way, just in general, the user interface has a pretty annoying thing of the labels going away sometimes. A quick way to refresh that is just to kind of slide up the screen there. So anyway, here's like for this noise one, we'll just put this basically back on that. Okay. And enable it again. So we've just got our icosphere and some vertex noise on it. You can see here we've got like this strength parameter. So like the higher we put that up, the harder the noise is applied. There's a bit of a naming convention that I've used with both the compute and geometry shaders here, where you've got like a, say for example, strength here. We've got a couple things about the strength default and strength buffer. And whenever you see a pair of attributes like that, what it means is it's a buffered input. So we can provide that with a spread of values through a buffer. The default is basically just a convenience. So if you've got a buffered input, it can be quite annoying to, if you only want a single value for it, to specifically have to make a dynamic buffer node and to connect an IO pin and set that up with the shader just to get it to work. So yeah, all that's doing is it's saying this is what I'll use if I don't get any buffer. So like the switch is off right now, so this just is like a node switch. So on one it's got a buffer coming in, on this one it doesn't. So internally, this guy's just checking if there is a buffer on that input, and if there is, then he'll actually ignore that default value. Otherwise, that's what we used. So this is just with one piece of geometry. We'll go ahead and pop over to the next patch and just have a look at when we want to do some instancing. So it's this one here.
Oh, by the way, the node which is able to merge together geometries is also available in MCR OPEC as well. I don't know if you have one in Instance Noodles too.
Yeah. I haven't used the other one, so I'm not sure. It might have a different behavior or meaning. But I'll cover the one in Instance Noodles shortly.
Nice. Whoop whoop. Yay, patch is starting.
Alright. So yeah, this is pretty much all of those geometry effects nodes. I should just clarify also, when I'm talking about these geometry effects nodes, I'm actually talking about the instance noodle modules. So if you're familiar with like the kind of texture effects stuff in 4V, when that was introduced in DirectX 9, it was basically like a module kind of design where there was a shader inside of it, and it was just being wrapped by a bit of patch stuff. In Instance Noodles, it's kind of a bit the same with the geometry effects and with the compute shaders. So for example, like if we look inside here, all of these have an actual GSFX file there. So that's the actual shader, yeah. But it's just got a little bit of wrapping. So you've got like the layout as just kind of stock standard. It's doing a little check on how big the geometry is, so it knows how to use. I should say this isn't actually the most like efficient or performant way of doing this.
Yes,
there's a few places where it's basically been designed with Instance Noodles to be as patcher friendly as possible. So there's a few ways, and we might talk about it later, that you can really optimize things a lot if you actually know what it is that you want to do. I kind of like having it just set up for ease because it's just much nicer if you want to improvise or to just try some random shit, and it's nice not to have to do all that boilerplating. So yeah, part of that, that said, so when I'm talking about the geometry effects from now on in this session, I'm just talking about these guys. Part of the design of them is they've all got input that says IID. So you've got like, yeah, they might have other things, but they'll pretty much always have a geometry in, an IID, and a geometry out. What that stands for is instance ID. So like internally, that's using like a system value where you know, if we've got multiple instances of the same geometry, it's just the index of that. And that's kind of how you can have control separately. So for example, here it's just like a tessellation shader. As you can see, the tessellation factor is different for each one. And this is a pretty important node for Instance Noodles. Basically, if you're gonna do any instancing, that's it. And what that node is doing is it's just wrapping the actual instancer. It's kind of just doing a pass through that makes sure that the geometry is friendly for the other modules, and it's also building that buffer. So it's just saying, basically, it's looking at how many polygons are in your model, and then kind of filling that out for a buffer for each instance. Hope that makes sense. we'll try applying it a bit. So yeah, this transform buffered one is also like a very frequent usage one. I'll just zap that grid. And what it's doing is it's, keep in mind, like the geometry that's coming out to our shader here is just a single. It's just one guy. And so this is where that IID comes in handy. So for example, this transform buffer is doing the same sort of transform that normally you do in the forward shader. So you know, like constant or whatever kind of normal shading thing, it's got a transform pin there. If we're working with it this way, we don't really need to use that. Kind of the point of instancing is it's drawing all these things in one call, because it is one geometry actually. I'll just show you what happens if I actually do this. Because it's important to remember, even though we've got multiple things going, the actual forward shader here is not spread at the moment. And in fact, if I so put a translate on him, you can see actually like we're taking the entire scene basically and translating it twice, which I don't know, maybe that's what you want, but it's something to be aware of. That if you're spreading this, then you're actually taking all of that geometry twice, which isn't really what we want. So this guy is taking a transform as well, and we can do it that way. And that has the advantage that we are just using our instance ID, so we can still send transforms individually to each one, but we're still free to use any kind of normal forward shader, or if we wanted to do effects on them. It kind of matters the order, you know, like for example here, we're transforming them and then we're tessellating them, which makes more sense. We could actually put that the other way around and tessellate them first and then transform them, but you've just got more points to work with then. But for example, if you imagine like we'll put a noise on it. We'll just get that same one we had in the last. Okay, so I've got a vertex noise. I'm gonna take the first. I'm gonna put it first. So I'll take the geometry and that guy. I don't necessarily need that one unless I'm doing something per instance on here, but do it anyway. And then feed that to there. Now you can see here. See how they actually all have the same noise being applied? Now the reason for that is we've got, if you think of all the instances, so there's already 6 copies of this geometry after this IID. That's what it's doing. But there are actually 6 copies in the same place in space. So when we apply this noise on them, they're actually all centered in the middle still, and that's why it looks the same. And then we're transforming them after. Sometimes you might want to do that. This would really apply like if you're using deformers and things. It makes a difference if you transform before or after it. But like in this case, if we want the noise to kind of distribute over them, it actually makes sense to put it the other way around. So we'll just disconnect those. Just gonna... Sorry, don't mind me. Okay, so now you can see we've got the same nodes there, but obviously order matters. So in that case, that's probably more what we want. We're transforming it first, and now you can see the noise function is different in the different places as we would expect. So I haven't really talked too much about using these buffer inputs. You've got like the dynamic buffer types for all the like each different structured buffer. I'm just gonna, for people who are kind of familiar with writing shaders, you'll probably know about this already, but just as a very kind of brief like overview, if you're just using it in terms of patching and not actually using the shaders, that's fine. But anytime you're using those buffers, it's a different kind of type that it is. It's going straight to the GPU, and then inside of the shader, it can access any index from that, which is really cool because like when you're spreading stuff with shaders, it's basically you might have like 3 values going into a shader, and then the shader has been called 3 times, and each of those instances of that shader will just have access to its own index when you spread a shader normally. So like instance 1 is just getting value 1, instance 2 is just getting value 2. With these structured buffers, you have a lot more flexibility in how you read from them. So pretty much any element of the shader can access anywhere into that structured buffer. So for example, here we've got a transform buffer. That's just, we might make a shader that creates that buffer, but if we want to make that on the CPU, it's always just these dynamic buffer nodes that upload it. Now, if that's something that's changing, then you probably want it on like this. If you just want to do that once and set it, for example, if it's just some starting values, or it might be something where it takes a lot of calculation to do, but then it's not moving around, you can take the supply pin off. So these ones have like a think all the dynamic buffer nodes have one of these. And if we take that off, the value is still there, the buffer is still there, it's still got access to that. It's just not having to upload that from the CPU to the GPU every frame. Generally speaking, we've got, I might actually skip ahead for a sec. I was going to do compute after, but I just want to open this one because it kind of explains a bit more with these. Oh yeah, sorry if there's some glitches. So this is just in the girl power folder, girl power compute. And that kind of just lays it out a bit. So you've got value, which basically doesn't make any kind of distinction between bit depth or whether it's an integer or not. Much like in 4v when you're patching, you just have values. And then you've got like 2D, 3D, 4D versions of that as well, which is just for working with vectors basically. For color, haven't given it its own type. It's just a 4D buffer, and then you've got transform buffers. And then these are kind of the nodes that Bux supplies in DirectX 11 for the dynamic buffer ones, or what pops it onto the GPU, and the let you get your data back from the GPU again. Generally, that's a really big bottleneck. You shouldn't really be reading data from the GPU unless you really need to and know what you're doing. And yeah, that's just something that'll kill your frame rate in general. So it's worth thinking about and how you design things. We'll just go back to. So with these guys, just gonna have a look at this instance ID one. Say for example, we want to
Are you alright? I can't really hear anything from you, Kyle.
Oh, is the sound gone?
No, it's back on. It's back on.
Hello?
Just a second. It's okay. It's okay. Just there were like a long pause. Nothing.
Okay.
Sorry about it.
Just, yeah. No, that's alright. Just let me know if it drops out. It probably will at some point. You can hear okay for the most part? Can you guys hear me? Yeah. Hello, hello. Hello.
You remember there's a very, very huge delay between the stream. So yeah, there you go. That's the delay. It's like 7 to 10 or 14 seconds. It's very, very good. Very, very big.
All right, so I'm just gonna change the transform here. No, I kind of want that to match the instance count, and we'll put apply on again there. Now, that's always nice when something goes wrong. Oh. So if we just have a quick look at this tessellation guy, it's not so much specifically about the tessellation, but let's just look at why it's changing the way it is. So we've got, again, one of these pins where it's got like a default and a buffer version of it. So the buffer and factor default. Now, because we've got a buffer attached to that, you can see this one's not having any effect. As soon as I detach that, and yeah, okay. So that's just if you just want to apply uniform tessellation, you'd only need that one. Now, a lot of these pins where you've got like default and buffered versions, you also have an indexing pin. And that depends a little bit on the shader, what sorts of options it might have. For these geometry effects ones, a lot of them just have, it's basically just like asking if you want to index it per instance, per primitive, or per vertex. I might just say a quick word on terminology there, because primitive basically like I think for a lot of people, if you think of a primitive, you think of like spheres and cubes and stuff. In terms of DirectX 11, primitive and topology kind of have their own meanings. So in this context, a primitive is actually like a triangle or a line, and topology is kind of how those primitives are organized. Now this may look like a lot, but actually for instance noodles, it's really simple, or shit, depending which way you look at it. But basically, we're only worrying about triangles, and we're only worrying about triangles in a triangle list. So again, it's probably not the kind of most performant way, but it's definitely the simplest and easiest, which is good. So what this means, I'm gonna make a dynamic buffer here, just so that it's a little bit clear like what we've got going on. So I'll take 3 values, and we're gonna put that into the factor buffer, and our geometry disappears. And that's because the tessellation factor is set on 0, which actually just doesn't pass anything. So you can see as soon as I put those up, we start getting some back. Okay, so we've got a tessellation factor of 1, 2, 3. There's a couple of things that these are doing when they're loading these buffers. You kind of don't need to worry about this from the 4v side. Basically, it's doing like a modulus operation on the buffer, which is pretty much how 4v behaves in general. So if you don't want to worry about that, you don't have to. But just to know, what that means is just even though we only gave it 3 values and there's instances, you can see the values repeated over the instances. So it's just the way it loads it. It's looking at how big the buffer is, and if it's got more, it'll just wrap that. So that's with the factor indexing on instance. Makes sense, yeah. Just if we put it on primitive, you can see now we've got something different going on. So might not be super clear, but we can see that we don't actually have like it's not doing it on each instance of it anymore. If I change these, we're only changing some of the triangles. And what this is doing now is it's taking the same buffer and it's wrapping that, but it's doing it on every triangle. So like, I mean, in this case, we've got a very small buffer. So we've only got 3 values, and then it's just repeating that over all of the spheres. But you can imagine also having a really huge buffer. So for, oh, sorry, am I talking too loud? So
for me, your volume is
might
perfect. There you go. It's all right.
Okay. So just adjust your television sets if need be. Yeah, so you can imagine they're having a really huge buffer as well. You might want to set the tessellation factor per triangle for the entire scene, for example. That would work too. If you have a bigger buffer even than how many are there, it doesn't matter. It will only get as far as it does. And then we can also set this per vertex as well. I'm not quite sure how that works for this one, but yeah, with these geometry effects, most of them, like if they've got an option for this, it'll depend on the effect, which ones of these actually make sense. But that's kind of just in general what that is. And keep in mind that this indexing, it's for that parameter. So it might seem kind of like a lot to have 3 separate pins for just one parameter. But for some things, it's just nice to have the flexibility. So you'll see this kind of pattern repeated a lot of a default pin, buffer pin, and an indexing pin. So basically, if you're using the default and only doing a single value, you can ignore both of these guys. If you're using this one, you can ignore that one, but then this becomes relevant. Yeah, all right. So we might go ahead and move on then. Does that make sense? So if anyone has any questions, just shout out in the chat. And go on to texture arrays in a sec otherwise.
We have to have like a signal sound for waiting for the latency. Like, do you have any questions?
Yeah.
And then go ding 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 ding. Anyway. Yeah, that might do. That might actually do. Is the sound effect. I think we can. Oh yeah, yeah. I think we can go on because the only question or only reaction we've got is a smiley face from Chris. All right. I can take Chris's opinion and extrapolate it to everyone, so I think we can go on.
I think he's a pretty good ambassador.
Yes.
Okay. So texture arrays. I should probably say like I haven't actually really done plugins much. I'm just learning it at the moment. So there's a couple modules in this that would probably be much better done as a plugin. At some point I get around to that. But anyway, this disclaimer is this is a extremely stupid module, as Mr. Bucks would say. It's just taking a spread of textures and making what's called a texture array. So a texture array is like a spread of textures, but it's just kind of got a slightly different, I suppose you could say, enclosure around it or something. It's a different resource basically. So it's still got all your textures in it, but again, you know, we were talking about how these guys aren't spreadable as such. You know, like if I took a normal pin like that, I can't actually spread that. The only way to spread these is when it's got like a buffer. So like this one, for example, we can spread because it's a buffer pin, although it's sending it a buffer, not a spread. That probably just sounded confusing. But anyway, the point being is in the terms of these shaders, a texture array is to texture slices what a buffer is to a spread of values in 4V. So where if I just took all of these textures and gave them to like a shader, that would be spreading the shader. This is basically putting them together, mushing them into one array, and then going from there. It's basically just, I think, looking at the size of the first texture, if I remember correctly. And that's going to be the size for your array. I believe with an array, they all have to be the same size. So just something to be aware of, that something kind of got one size. You can make a texture array from a shader or a plugin. This is just a convenience node for if you've got textures to make an array of them. So that was probably a backwards explanation. The whole point of this is control maps. You can probably see that here explained. So obviously, like with a control map, you're depending on the UVs from the mesh. I'm gonna kind of assume everyone knows what UVs are. If you don't, maybe go look them up on Wikipedia or something.
Quick
But
hints, it's texture
it's
coordinates.
just what's that?
It's just quick
Texture
hints.
coordinates.
Yep.
Yes. So yeah, obviously that depends on your model and how it's been UV mapped. But it can be really useful in some cases because you can have a lot of control from that. Yeah, a geometry shader internally, it really doesn't access kind of the whole model. It's just like the triangle it's on. So using control maps can be a nice way to have like a more sort of holistic control. So yeah, we've got like here. There's a couple things going on in this ugly patch. But like if I disconnect this, you can see we've just got the sort of geometry itself there. So it's using the same texture array twice actually, or maybe even more. So yeah, you've got like, if we look at the tri-frame, that's probably a good example because it's got the different options of how to control it. So we've kind of talked already about if you've got this buffer and indexing, what that does. Here we can see we've got the same value again, but using the texture array. Now this does not have an indexing pin. Basically, any of these that have texture array controls, it's always applied per instance. Means that we have one texture for each instance, or more correctly, it's indexing through the textures by the instance ID. So we don't actually have to have the same number of textures here as what we do. Again, it'll apply that kind of modulus. So like if I only put 3 textures, then we've just got it repeated twice, as you can see. Most of those control texture ones are, I think actually just about all of them are just using grayscale maps. So it's basically just doing like the same thing as yeah. So here, for example, we've got it on the width. If I just disconnect that, I'll turn the noise off as well, so we're just only looking at the tri-frame effect. Make this guy's a little bit fatter. So this tri-frame takes your triangles and makes a lot more triangles. It's not very performant, but it's fun. So yeah, I mean we've got our single input. It's just doing that, yeah, and then we can do the same thing with a buffer. Or in this case, that's what we're doing with the texture array. So I mean, at the moment we're just using some noise on that. But for example, we can use anything from all of the very nice texture effects. So I'm going to put a gradient on it. And you can see there sort of an example of, it's good for visualizing the UV. And we can. So that's kind of cool. Because with texture effects, they actually, you can spread them. So for example, if I just want to look at the gamma there. With a spread value on that. Spread it over all 6. Yeah. So I mean, the textures aren't terribly different in this case. But yeah, you can see we're using all those different slices, and it's just going one per instance. The actual implementation of ones where it's got both a buffer and a texture array is a little bit different depending on the shader. So for example, you can probably find just by messing around with it. But you know, in some cases it might add the default or the buffer value to the texture array value, or it might multiply it if it makes more sense, or it might even just take one of them. Yeah, all right. So I'll probably keep going then if everyone's cool with that. I'll just wait like 20 seconds and slurp my coffee some.
That's slurping the official waiting music now.
Dun, 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 dun.
Considered as an avant-garde art group. Yeah. Meanwhile, I'm preparing something which you guys might be happy about or not. I don't know. It is basically just good for weekend workshop. I don't know how good it is, but yeah, 20 seconds off and back to to Kyle McLean. Kyle, the word is yours. Say something.
Alrighty. So, to finish up on the geometry side, I thought we'll take a look at that merge node I was saying, and we'll also have a look at actually exporting geometry. So the Instance Noodles comes with a geometry writer. It's very, very basic. It just writes to OBJ. But it has a couple of features that are kind of made to work with the instancing ID and stuff. So we'll have a look at that. But first, what I want to maybe just go back to for a second is, you know, when we were on that first one, we had a look with more than one geometry, and we found it didn't work. So I'm just gonna take a box and a sphere here.
Ooh, what didn't work?
So we were just looking before, you know, I'm passing a sphere at the moment into this chain, yeah? If I pass more than one piece of geometry, I mean, we didn't see a change then, but yeah, like if I switch the order, we'll see we're only getting the first one, basically.
Yep. Sorry, that was my mouse.
So that's kind of what this, well, one of the use cases for this merge one is. Hopefully that's got a help patch. I think it does. Yeah, good.
Show me the contents of that merge because I'm curious. Nice, very nice. Yep.
So the yeah, pretty much just passed through.
Yeah, that's basically the same. Only difference is mine supports different input elements as well. But yeah, for most use cases, this is
so there may be a better merge you can use then. Is that in the in the micro pack or?
Yeah, it's an MCR pack, and also mine uses mine actually writes the subset IDs into the geometry itself. So it uses a separate semantic for the subset ID.
Yeah.
I don't know if
this actually does do that as well. So it's writing the ID into a color actually.
Yeah.
But it's kind of, yeah, exactly. So that's kind of only difference from the really standard layout.
Yeah, the thing is that that color.
And then it's got a oh, sorry.
The thing is that in the future of Instance Noodles, you might want to consider that you can use whatever semantics you want, and you can make.
Yeah, it would probably make sense to leave the color slot for
actual color.
Its intended purpose.
Yes. And then create your own kind of. For example, in MS, I have a previous position, a pref pos semantic, and after that a subset ID semantic. So.
Yeah, that's probably something good to look at changing. Which I should say in general also, Instance Noodles is kind of pretty naively implemented at the moment, so it probably will change some. Stuff probably will get broken.
Yeah,
like
breaking changes. I do that all the time.
Fair warning, you know. Like yeah. So basically, all this node's doing is it's taking multiple geometries. It's kind of rendering the primitives basically, and then merging them into one, and creating one of these IID buffers for it as well. So like as we were saying, actually that information is in the geometry itself. It's kind of just a ease of use thing that's got a separate shader that's splitting that out to use in the patch. So if we look what's actually going on here, this isn't actually the simplest use case already, because what we actually have is multiple geometries that have multiple instances. So probably the simplest use case would just be if we just have like if we just have, like we were doing in that other patch, we just have one box and a sphere. Comms geometry. It may not like this because I've still got the old instance IDs there. Okay, so that's basically just shows that it's working. This axis is getting annoying, isn't it? So we've still got the geometry going through a geometry effect, but it's being applied to both of them. So what the merge is doing is it's taking these guys and turning them into one. So in simplest case, we've got like one whole geometry, another whole geometry. The instance bin size is 1 because there's just one of each of them. In the case of like having more, or maybe we want to add a number of cylinders to that, I'll put in their input on there. So we'll say one. So the cylinders on this instance ID, we've got 3 of them. So I'll put that like that. So this is the instance geometry here. Put that there. And that there. And I'm not sure whether it's not more of them. Anyway, basically there's a couple of use cases for that. You can use it to merge together different geometries like this, or sometimes it can just even be useful for just a couple different instancing sets. It's just kind of a convenience way, and then you don't have to use multiple chains of these if they're having the same effect on it. I want to kind of keep moving because it'd be nice to have a look at some of the compute stuff as well. I kind of made the compute nodes originally just because it made the geometry ones more flexible, but they are very general purpose as well. Most of the compute ones are really, really simple functions or clones of 4v nodes. But yeah, just the idea of using them in a modular way. So like even if you are writing shaders, there's probably a lot that you can just copy paste out of there. Just a question there. Is it actually morph two geometries together?
Sorry, I couldn't catch it. What was the question?
Is it actually synthesize morph two geometries together? This one's not doing any morphing. It's basically essentially all it's really doing is it's like a cons for geometry, but it's merging it into a single geometry. If that makes sense. See here how we've got this 3. So you've got like multiple subsets of geometry are going into this. It's always, no matter what this is being given, it's always one geometry that comes out. So it's a sausage factory basically. You don't need to know what happens inside it. That's how they're made.
It's a magic box, yes.
There is actually a morph node. So yeah, I mean this one basically you're two different geometries. You've got your geometry and your geometry morph target, which is basically just like geometry A and geometry B.
Nice.
And then you can morph between them either as so like on default it's just morphing the entire model, or you can do that via buffer. I don't think that one's got a texture array control. That'd be alright too. But yeah. And,
yeah, texture control can be very, very tricky in this case.
I think it'd be a not so hard thing to add. We might even look at doing that later. Where was I? Yeah, just with this morph one, it's it kind of expects that you'll have the same basically like the same same triangle order and number, if that makes sense. So it's essentially the same model. If you feed something different there, then you'll probably get really glitchy effects. So, but to have that morph effect, it's kind of assuming that you've got the same structure. So you can see there. I mean, it'll still do something, but if you want a smooth effect, you kind of need to prepare your models accordingly. Does that answer that question? Not sure
which question was that? Does it morph or what? I don't. I think it answers that question anyway. But whatever you refer to as question.
Okay. So the last thing we'll look at quickly with geometry is just the rider node. So if we go I think it's that first one. I should tag that as noodles as well. Yeah. Okay. So we've got some geometry. We've done something with it. Cool. Good. Let's say we've put some effects on it, whatever. I know the boxes look kind of boring, but pretend it's something nice. The point is that they've gone through like some geometry effects already. That's actually what's transforming them here. So if basically with the rider node, you're giving it the actual geometry. I'll just get the inspector on top here. Okay, so you've got the actual geometry. That's pretty self-explanatory. It's got an IID pin as well for the instance ID. You don't need to use that unless you have use subsets turned on. So I'll go ahead and export this. You can say whatever file path you want. In this case, because we're just saying the name, it's gonna write that wherever the patch is. So in our it's in our packs thing just next to it. But you can put that path wherever you want. So I'm just gonna fire up Cinema 4D for a second. I'd assume you could import it in whatever suite you want to use. But so yeah, that's just our. You can see the models there. As it is, this is one model. So like even if that was like a big swarm of things or something, it would still be one model. So hello labels. So I'll turn use subsets on, and we'll export that again. I'm just gonna reload that here. You can see now we've got the same loaded in, but it's got it kind of numbered by instance, which depending what you want to do later can be useful. You can do things on them independently then. And I mean, that's just with a few cubes, but it'll work with more things as well. I haven't tested it very thoroughly, but like I think it worked with 5,000 cubes. If you want some cubes, pretty sure Cinema 4D can make cubes, but there you go.
Well, if we put the writer patch inside another patch, which kind of controls the evaluation of that patch, it can be alright. So this workflow.
What's that? Sorry.
Is that just make sure that for the user, or I don't know if you put that patch into evaluate as well, but make sure that the writer patch is put inside, or the evaluation of that patch is controlled from outside, if that makes sense.
Yeah.
You have an evaluate hidden pin in every sub patch.
Yeah.
In the inspector.
Yeah, there's some fairly nasty stuff going on in that writer patch that you definitely don't want having on all the time. Yeah, I've kind of tried to use some, like sample and holds inside it so that it behaves for the most part. But yeah, that's a really good point. I mean, every node in 4v actually has this built in. If you didn't know this, it is hidden by default though. So like if we look at this axis and grid one. Oh, hang on, I've got that attached. You can see it's got evaluate there, which we just click to make same here. It'll add that to any node you make. So if we sorry, I'm just trying to get that patch. At home, I'm nice and used to using like 3 monitors, so I'm just on the road at the moment. But this is the icky rider patch. Yeah, so it's got a bit of readback and stuff, which yeah, you basically you don't want on all the time. Yeah. Yeah, but anyway, you can see in Cinema 4D we've still got kind of individual control over each one, which is cool. And then you could stuff here and then bring that back into 4V and do some more stuff there and then bring it back here. Whatever floats your boat. I think that concludes our Cinema 4D section. So I think might go on to compute stuff then. I'm actually just going to go to the bathroom for a couple minutes. Maybe David can entertain everyone until I get back.
I don't know. I don't have much idea, and I have only one monitor here, which is just cluttered up with everything. So we might.
I'll be back really soon.
Yeah, I will just put back.
Get rid of some excess coffee.
I just put back this on and watch this.
Yeah. Maybe you can sing them a song or something.
Yeah, Silent Nights or anything. That would be really creepy, to be honest. Well, yeah. Well, I will probably link this in the video, so we will have like a little break here. So I'll see you in a couple of minutes.
Yeah. All right. Hello. Just give a hi if you can hear me okay.
Oh yeah. So did you hear anything I said? Because I was muted. Sorry. So I was just saying that the stage is yours. So I switched you back to your desktop.
Yeah. So we'll kind of have a more of a look at the compute side of things now. There's quite a few nodes there. So like if you look in the pack, you've got kind of the compute folder there, and basically the nodes are just categorized after the data type. So you've got value buffer, 2D, 3D, 4D, which is basically just the vectored versions of it, and transform buffer. And there's a fair few nodes there. So we've got like, you can see that they're just kind of categorized after the type that it is. I'll open that kind of overview patch again. So yeah. So just kind of a word about these buffers in general. I mean, if you're using DirectX 11 a lot, you probably know all about buffers, but if it's sort of a bit new to you, there's nothing kind of particular to Instance Noodles about these. They're just like buffers are what all of the shaders can use. So I mean, you can use these effects like on the geometry effects, but you can use the buffer in any type of shader basically. So it might be you know, in a vertex shader, in a pixel shader, pretty much anywhere. And it's quite easy to actually add that into a shader to support a buffer. We'll probably actually have a look at the end just quickly how to do that as well. So yeah, you can see there's sort of a little bit of a structure to the modules themselves. It's a bit like old school texture effects in that it's kind of the actual effect file plus some wrapping for it. I'm not gonna really cover much about kind of compute or how it works under the hood. I don't know that much anyway, actually. As I said, this is pretty naively implemented. But I'm just kind of wanting to look at the module structure, because no matter what the function is, they pretty much all have this same structure. You've got your kind of main input and output, which is usually of the same type. Some modules might take one type and return another. Like this noise takes a 3D buffer and gives you a value buffer back. But yeah, they kind of follow that texture effect template. So for example, in this case, if I turn this guy off, he doesn't keep outputting anything, but they've all got a switch to, you know, if we take that off, then it's not as interesting. Yes. There's a spread count. This is kind of important. Basically, it's a little bit of a pain, but when you're making a chain of these guys, you need to put the spread count for all of them. And that's just telling the shader how to dispatch it properly. If I have this smaller, then we'll see that they start to disappear. It really needs to be given the proper spread count. It can't really just wrap that or something. So in terms of the actual nodes themselves, most of the compute nodes fall into sort of one of two types. They're either like a clone of a 4V node, or just a wrapper for a HLSL function. Sometimes they're slightly different, but you know, for example, polar is actually they're often named the same, but you know, polar would actually do both polar and Cartesian. You've got polar to cart, cart to polar. Again, if you want to have a look, you know, say you just want to play with 3D buffers or something, if you go into the node browser, you can type noodle and then what type of buffer you want. So if we say buffer, let's say 3D buffer. And you can see then it's come up with all the ones that'll use that data type. There's probably a couple like really frequently used nodes that's worth kind of mentioning. The one that might not be obvious, but you're definitely going to use is just a simple operation. and that's your, your add, subtract, multiply, divide. Now in 4v, if you're using like a plus, it doesn't really make a difference if we're using a vector or not. I mean, 4v, we'll see that as a spread, but in terms of our result, we don't really need to take care for that. So, it's the same normal plus node I'm using in the patch here. If I have a vector going into that, it doesn't actually care. I mean, it's a spread. With the compute shaders, it actually does matter. Generally, if you've got a 2D vector, you'll use an actual 2D buffer. So for some of the very basic nodes like get slice or this operation one, you'll see it's actually got just another version of the same node. It makes a little bit of duplication in the patches, but oh, hello, you still here? But it just means that we can support these other buffer types. Cool. So I mean, inside of these, it's actually pretty much the same wrapping, even the same code more or less. Main difference just being is that if we look up here, you can see the actual kind of its output is a float in this case, and it's got the correct amount set on the render. And here, since we have two floats, it's a bigger stride. You don't really have to worry about all of that. Again, if you're actually making something that you want to use in production, a lot of this can be optimized. There's some, if we've got a chain, we don't necessarily need like a render for every module. It's just in terms of like having some patching improvisation, much easier to not have to make a layer and attach them all and give them semantics and yeah.
In compute shader, it is a little bit wiser to chain them up with group layers, because for example, you can set a common dispatcher on the group on compute shaders, and then have that dispatcher considered throughout every of the effects files, so you don't have to connect your dispatcher to all of your effects. And also the beauty and also the beauty of the compute shader pipeline or the effects pipeline is that you can modularly define the order of your execution on a single buffer. So I might suggest considering supporting that pipeline as well, so you don't have to create a separate buffer to every simple operation after it. But
yeah. I did actually do it that way some as well. I ended up going back to this. The other is better, and like I was saying, if you're using it in production and you need a good frame rate or something, probably definitely go the other way as well. There's a few places where, like with this pack, I've kind of just taken ease of patching as a higher priority than it actually being what's most performant.
It definitely takes.
And even that, sometimes it can be different depending on your use case. If for example, like at the moment, in this way, it's kind of a pain that you have to put the spread count onto. So see, we've got a spread count here. That's got to go to every single one in the chain. Yeah. If we were doing it in a group, we could set that by a semantic or something, and that might even be easier than, we simply set the spread count once and it's everything. But it just depends. Like as this is now, if we only want one or two, we can just make them, and we don't need to worry about all of that kind of extra. So it depends on your use case. I might try to make it go more that way at some point. I'm not sure.
And most of the DirectX 11 particle systems out there in public, and most I've seen, they usually have like a wrapped renderer, so you have to use it. It's like a mandatory node to use it, and then the operations on that particular system in separate nodes, which you have to group them together, turn them off, dynamically. But those nodes are more for more particle systems. As I can see, this is very much more general purpose.
Well, that's part of the idea. So I mean, you've got these compute nodes that, I mean, in these examples, I'm using them with Instance Noodles nodes, but you can use them with any node. And with having just them follow the sort of structured buffer types, you don't actually need like a converter or anything. You might have like a pipeline of effects of these, but you can at any point take the output from it, and it's just going to be like one of these kind of standard types, so you can have that in a normal shader at any point without having to go between like a special layout or setup or anything.
Yeah. Well, go on.
So I'll just go back and compute one. Have a quick look. There's I haven't written many source nodes. There's a couple there. Was playing a little bit with like having them bin sizable as well. So like I think there's only a couple. I might have done some other ones, but like you know, these are kind of just your spread generators. So you've got linear spread, which is just giving you a value buffer. You've got I spread, which even though it's integers, it's also a value buffer. Wave spread's a value buffer, and just as its own, there's a 3D buffer from circular spread. So yeah, like you can pull these buffers from lots of places. There's if you want to take it from a texture, there's some nodes to sample a texture from. So, you know, this takes a UV buffer and we can sample from a texture to get a value buffer. You might upload a buffer just with the dynamic buffers, or these ones are kind of just standalone, so it doesn't need a buffer going into it. If we have a look at this, it's kind of pretty much like a normal linear spread, but we've got, again, this sort of default and buffer sort of thing going on. So we don't actually need to give this guy any buffer at all. He's going to make a buffer. It's just coming from the spread count, and then like internally, that's just being used to make offsets and stuff and build the spread up. But if we want to, so for example, in this case, you know, we've got a different bin size for it. It's a little bit of a special case, these bin size pins. You know, I was saying with these compute ones that they're not spreadable, it's just the buffers. With the source ones, when they have a bin size pin, it's basically saying, yes, you can spread the spread count. And then this gives you a little bit similar to the instance ID, but not quite the same, as it's got a bin and ID buffer. So this is actually a 2D buffer. And what that's doing is, at the moment it's hooked up, we've got a color buffer in the sprites here, right? So I've got a very small buffer. I've just got 4 colors, but we're indexing that with this one. So at the moment we've switched that. It's using the bin. So you can see we've got basically each spread is having its own color. If we switch that over, I think that's a pretty good kind of graphic example of what the second component of this is doing in terms of the ID. It's just so if the first one is telling you which of these kind of bin groups it's coming from, the second one is telling you, okay, I'm the first instance in this, I'm the second instance in this, and so on up to that, and again 0, 1, 2, 3, 4, 5 up to 22 for this. One thing kind of good to know is there's this is a 2D buffer, right? And here on the index buffer, this is a value buffer. Just with that naming, basically anytime it just says buffer on these pins, it actually means a value buffer. If it's a different type, it'll say 3D buffer or transform buffer or whatever. So this is just taking a single value. It's a value buffer. If I connect this 2D buffer straight to that, it's actually the wrong type, but it will handle it. It'll just take the first component. So if it is actually the first component you want, if you want to index something by bin size, you can just attach that directly. So I'll just move this out of the way for a sec so you can see. So that's just going straight from this. So even though that's 2D, it's just taking the first component. Otherwise, if you need to split or join these, there are some vector nodes provided. So we've got like we've got 3D split, 4D split, 2D split, 2D join. Should probably have some like joining ones there. Yeah, but that's just kind of, I think it's pretty clear. It's just like the buffered version of doing these. So we'll have a look at another one. So like this is the help patch for circular spread. And same kind of thing. It's just using, in this case, since we're just doing the color by bin, we're not really having to worry about. Yeah, and again, you kind of have to make sure to attach this spread count to each of these. Like I was saying before, Instance Noodles isn't really concerned with rendering. It's a little bit more just this abstract kind of compute simple modules and some of the geometry effects. That said, there are kind of a few shaders there. Partly because you need something to see what those buffers actually look like. So yeah, very kind of basic. I think there's just like some buffered versions of constant and grow. I didn't with the compute shaders, you've got these source ones and filter ones. I kind of didn't really mention it with the geometry. We were just looking at the filters, but there is some source ones for geometry as well. So if, yeah, so you can kind of see here, there's like the geometry effects, which we were looking at before, and there's a few source ones as well. The cylinder is actually just a replacement for the stock DirectX 11 cylinder because it doesn't have texture coordinates. I believe that's actually going to be fixed in a newer version.
What, the cylinder? It doesn't have texture coordinates? I'm pretty sure it
What's
has.
that?
The cylinder.
I think it's been fixed. It didn't used to.
It's been fixed. I'm pretty sure it has because I've used cylinder with textures before. It was cool. What I miss from the built-in primitives are actually tangent vectors. So that might also be a thing.
Oh, to make like parametric versions. Yeah. Yeah.
Not the tangent vectors for to use normal mapping.
Oh, to have yeah.
That's the only thing what I miss. Go on.
So I might I feel like I've been talking a lot about these compute ones without actually really using it much. I'm just thinking it might be good to just maybe open another help patch that can demo a little bit of a chain. I think this is in the pack already. If it's not, it will be. This was just messing around with, I was making some GPU-based UI controls. So this was just kind of playing with a slider sort of thing. So I'll explain the patch a little bit. Do you guys have this one actually, or I can use a different patch if it's not there? I think it was uploaded already.
Let me check. I've downloaded the OS from the contribution. I don't know if that's up to date or not, because I haven't know about the GitHub version. Oh, actually, I have a running video. I don't have to. What was the node name again?
Sum up. It's actually again there's a kind of a native 4v, or not native, but a module in the 4v library at least. It's kind of just copying.
I never used that.
So you can see like with these ones where it's just named after a node, you can see like you've got sum up value, which is the 4v node, and then this is basically mimicking the functionality of that, but as a buffered version.
Yeah, it doesn't seem to have that. Yeah, it looks like
okay.
It's a future update.
Yeah.
So what does that do?
Okay, well, if we take the normal sum up node, it's basically very useful for things like sliders, or if you imagine having like an endless encoder. So you know, like when you've got a dial that you can keep turning in one direction, like you might, for example, want that where, you know, if you keep turning, you get to a value that's the maximum, but then if you turn the other way, you want to go down again. You don't want to have to go all the way back.
Okay.
That's the kind of use case it's for. So like it's used a lot for sliders and things actually, because you know, if you keep dragging, if you think of a slider, when you go up, it only goes to a certain point, and then you might keep dragging up, but you actually still want to come down once you start dragging it down again.
Yeah, that makes sense.
So I mean, it's kind of actually a pretty sort of simple functionality, but it has a frame delay in it, which is one thing. It's kind of why I wanted to use this as an example. You can patch quite a lot of functionality in parallel with these GPU nodes, with the compute nodes. One kind of pain point is when you have these feedback cycles. Now you can do that in a compute shader because you've got read-write access on its output, but to patch that is a little bit of a problem point. So for example, normally for like a node that has a bit more functionality like this, you could just patch it out of the more basic nodes. In this case, had to kind of make its own one because it has that feedback loop there that's just happening inside of the shader.
Yeah, that's what I was talking about. That when you have this kind of when you want to mimic this data flow behavior, you sacrifice the read-write nature of your source buffer. So you either want to introduce a frame delay somehow. So you have to write a plugin for the buffer's frame delay, or yeah. So that's the only kind of disadvantage of this pipeline.
Yeah. Exactly. I mean, if you're doing some shader writing, it's not such a big deal because you can kind of just make the node and functionality that you need. But I just want to sort of say that as a gotcha. But I wanted to just explain this help patch a little. It's using the compute ones in a bit more of an abstract way, and that's kind of the idea I'm trying to get across, is that it's not just like a geometry effect or a specific effect. You're just using generic data. So like in this case, we're using that slider thing. So these are actually sliders. You can see it gets clamped to the top there. But we've kind of got this like brush sort of thing going on. So we've got like a size for it and a gamma or a softness value. Yeah. Could make a little voxel or something. But the way that is working is actually just patched here with these guys. So we might just have a quick look through that chain to see how it goes together. So we've got kind of our sort of source position here is just a linear spread. You could use a normal linear spread and a normal cross and a normal translate and put that all into a transform buffer. Here we're just using the compute versions. So this is it's a linear spread, but it's already on the GPU, so you don't need to upload it. So we've got our 3D buffer coming out of this. Yeah, which is basically that's just the position of the boxes in that grid. So that's being translated there as well. That's going to this distance one. So this is just calculating the distance of the vector, and we're comparing that from the mouse. So we're getting out of this a value buffer. So this is one of those nodes which doesn't actually return the same type that it gets. It's just comparing to 3D vectors, and we get the distance value. The map node is again one of those frequently used ones. So we're just basically we can give it default values for in, out, minimum, maximum, or we can do that like individually per slice if we want to give it a buffer. And we've got the map type. So what's going on here is if we look at those inputs, it's basically taking a range which is coming roughly from the size of the grid, and we're just normalizing that. So we're getting out of this a value of 0 to 1. Then we've got that it's being normalized over that size amount. Then we've got a gamma node. This is probably a good example. I guess there would just be yeah. So it's just doing the same thing. That's your CPU version. If you see here, it's generally, it'll come up even the same place in the list. You can see for each one of these, it's hidden here, but again, they've all got that spread count attached, so it's pretty important.
In this very case, you're most welcome to use send and receive nodes, by the way. So if you have like a global value of a global variable, then it might be more useful to use it in your project, not in your modules, because that can.
Oh yeah, that's right. Yeah, and obviously, I mean, you might have multiple chains of these as well. So you might, for example, want a different, for example, this one's a compute one, but he's got that, and this one's got that. You might have another chain over to the right here that's got 20,000 in it, or whatnot. But yeah, there's.
You have to either create multiple send receive nodes for that, or like back your buffer counts in some ways. Like use objects for example. Yeah. But yeah.
So so we used the gamma there just to soften that brush, and the only other thing is we've got like a color queue here. So this is just like the GPU version of a color join, basically. And we're using a max node there. Can't remember why that's there, but it's there.
That might have some crucial functionality which you don't remember.
Well, I mean, this is only for the color guide. Basically, it's not actually changing anything about the values themselves. But anyway, this is, I mean, it's moving this kind of grid of guys. But if you think of this as actually being sliders, which it is, it's 0 to 1. You can imagine that being mapped to all sorts of different things as well. So I kind of had made Instance Noodles largely to be friendly to people that don't write shaders. There's lots of cool stuff in DirectX 11, but it can be a little bit hard to access if you're not writing higher level shading language. So that was kind of the idea behind it. Oh yeah.
Nothing. Go on.
That said, I'd kind of like to, before we stop, just have a quick look into some of the shader side of it. Because yeah, like if you do write shaders, it's still a useful library. There's lots of functions there. And I just wanted to have a quick look at the Instance Noodles fxh file. Because there's a couple functions there that are useful just in general. And in particular, if you're wanting to make a shader that makes use of these buffered inputs. So, you know, for example, like this is the you know, here we've just got a constant shader, but it's constant buffered, which is a bit of an awkward name, but it's just basically saying that this shader is intended for use with buffers and not with spreads. So again, we've got all those sort of defaults and buffers, and if we have a look inside, you can say first up we've got just in the Instance Noodles pack in common, you've got Instance Noodles fxh. And let's just have a look. There's a couple functions from that just make loading a buffer much easier. So if we wanted to add a buffered input, we've got this structured buffer declaration here. So it's just like where you'd say, you know, a float or float 4. In this case, it's a structured buffer of type. So, you know, that'd be float 2, float 3, float 4, 4 by 4 for transform. You can see there's a buffered transform. And then when we go to actually load it, in most of these Instance Noodles ones, it's using this bload function, which is just short for buffer load. And you can see actually it's using that function for all the buffers it's loading. So you can see it here for the position one, or sorry, for the transform one. And here it's doing it for the colors. And so that's an overloaded function, which all that means is that you can actually use it with different types. If we look in here, we'll see it's just because it's got a different signature. So the signature is just like when you've got a function, it's the parameters or the arguments that you're sending to it. So you can actually have the same function multiple times, and the compiler is okay with that because the different ones have a different signature, you know. So it knows that, okay, if I get a structured buffer of type float 2, it's this version I'm going to use because that's in the signature. If I get a structured buffer of type float 3, then I'm going to use this version.
Okay, this is called function overloading.
Yeah.
Yeah. It's it can be done in HLSL as well. But note it won't differentiate between the functions with the same type of parameters but different return value, that the return type, it can't do that. You always have to use
that's a good gotcha to know.
Yeah.
I found that out just the other day, actually.
Yeah, that's kind of it's kind of understandable because to determine what return value would you like to use if you have different if you have the same type and the same amount of parameters, you would need to do very heavy context sensitive things in the compiler. So,
yeah
that's
yeah.
I think Microsoft in GPU you don't have that kind of luxury. So sorry about this. It pops up sometimes with TeamViewer. So go on.
So I'm just gonna pull up like a compute example. Okay, these ones don't actually have it. If you've looked at some compute shaders before, you might see that there's some kind of really repeat tasks going on in terms of, like checking how big the buffer size is. So there's a couple of helper functions for that. So pretty much there's just two really simple functions here. You've got bsize and bload, and bload actually makes use of bsize. So all bsize is doing is it's basically getting the spread count of a buffer. So it might sound obvious because you're already specifying that in the patch. Already saying, hey, this has got this spread count. So you might wonder why it actually needs to have that. And the reason is that even though we've specified like what our main spread count is, we might have other inputs that are also buffered. So for example, like even with a simple operation, we've got value buffer A and value buffer B. And so we're telling it like how many we want. We want 4096 threads. That's how many elements we're going to process. But if you've got multiple buffers, those might be of different sizes. And so like what we want again is the same behavior from patching in 4v, where it's got that modulus operation built in, so that you don't have to worry about like out of bounds access. So all this guy is doing is using kind of this is the HLSL function, the intrinsic function for just getting the dimensions of the buffer. But it's kind of a pain in the ass to have to do this for every one that you've got. So it's just kind of a wrapper to make that a little bit simpler. You just get your size. So it's just bsize and then the buffer type. So bload is making use of that. So it's basically a safe buffer load in the sense that if I in my shader, if I'm using bload, like here, for example, for the colors, I don't need to worry about if I've only got 3 or 4 colors I'm sending to that buffer and 60,000 elements. It's just going to safely wrap that. So for the bload function, it's got three arguments. The first one is just the type of buffer that you're wanting to load, or rather the actual buffer, but it'll be a buffer of a particular type. So I mean, here that would kind of relate to something in my input pins. So I've got vcol buffer there. That's declared as a pin. So that's what's exposed in the patch. The second argument is the default value. So this is the function that's basically making all of these ones where it's got default and value. And the third argument there is the indexing. So it's gonna step through this buffer using this indexing, and if there is no buffer, it's going to take this value instead. So it's actually pretty simple, and it just makes implementing a buffered control a lot faster and easier. Yeah, and then you can see for like some of the ones, you know, where we're using an interface here, for example, like where we want to change the color indexing. What we're doing there is we're actually then using you know, I've got this color ID one here, which I'm about to use the load there. So instead of using the instance ID, we're using the color ID, which is coming from that interface. So that gives options of how to step through it. Just to relate that to what we're actually seeing. I don't think we're sending it a buffer at the moment, so it doesn't really matter. Oh yeah, yeah, there we go. So you can see that's not how we want it to work, but you can see the difference there. This is how it's indexed. All right. I think that's probably most of what I wanted to cover. If there's any like questions or anything, feel free. I should mention also it is on GitHub. I'll post the link for that, and I'll probably put it on the contribution page as well. People are very, very, very welcome to contribute to it if they like. It's open source. The library is just like under CC attribution, which means you can use it for commercial projects. Just ask that you give a production credit. Yeah. Hang on, I'm just gonna grab that link now.
If you have any other components you want to talk about, we have still plenty of time.
Not really.
Okay. In that very case, I might ask you some other jazz, not really related. Like a couple of weeks ago, it had been a couple of months ago. Some time ago, you teased us with. I will put that on a YouTube description, by the way. So you teased us with 3D Patcher. How's that going?
Oh, yeah, it's kind of interesting actually. Yeah, I'm not working on it at the moment because I don't have a headset with me.
Mm-hmm.
It's at home, but it's actually yeah, kind of a patching environment for virtual reality, using 6 degree of freedom hand controllers. So I don't know. I can't really. It's a bit difficult to show you without the setup here.
I can imagine.
Probably show you like a screenshot or something.
Yeah, I think people would like that. Because in my opinion, it's a pretty interesting concept. So like patching in words, and the realization is very interesting, as you can see about the sub patches, and I presume that is a sub patch in the transparent circle.
It is.
Wow.
I mean, it's kind of all very much going through prototypes at the moment, so it's not very formalized. Like it won't work very well as a library at the moment or anything. But yeah, it's pretty fun. It's a lot to get head around trying to sort of. It's built on top of 4V, but obviously the graph works a little bit differently.
Yeah, it's not the easiest to get.
It's kind of interesting. It's a little bit different from what's normally done with, like, you know, when you encapsulate something normally, it's kind of what's wrapped inside of a function or what's wrapped inside of a node in the case of visual flow programming. which is really useful to kind of hide away the things that you don't need. But I think like it's probably familiar to most people that program how it can be annoying sometimes when you have like a function inside of a function inside of a function, and you want to get at something like it's a couple layers down. It can be annoying if you have to, you know, make that in each level of the interface. So playing with some fun stuff where you can kind of, without actually changing the module definition, you can still have things which are, it's kind of a bit like in a 4v patch, just the information about where the node is. But in this case, the pins have that information as well, so you can pull them separately. And it has the nice side effect of being able to do things like, you know, if we have a pin that we don't want, we can put it inside of there, or if we have one that we decide we do want, we can just grab it and pull it outside, and then it's accessible in the rest of the patch.
Yeah, you can
some interesting things as well, just with being able to kind of scale the pins individually, because you can kind of use that for like visual cues and things. So, you know, along with the strict kind of syntactic definition of a node or a function, you end up with some kind of less formal cues as well of just like, you know, things like this pin is actually more important than these two. It's like in 4v you have that as well, you know, where you might hide a pin or have it inspector only. You can kind of use it that way as well, but it's a little bit more like you know, it's a bit more analog.
Yeah,
makes sense.
You can call it maybe organic patching.
Yeah.
It kind of looks like on the
which I kind of like, you know, if you do some mind mapping on a piece of paper or something, you kind of have a lot of like details in terms of emphasis or position that it's quite easy to lose in a patch when everything is very sort of standardized.
Yeah.
So yeah, at this point this is kind of super like early prototyping and stuff, but I do have ideas for it. Really at some point would love to see it as kind of a multi-user collaborative patching experience in VR.
With leap motion, for example.
Yeah, whatever kind of inputs you like. I'm kind of trying to build it from the beginning to control.
Sorry guys, TeamViewer got messed up. TeamViewer session has timed out and will be closed. Oh jeez. But let me try to reconnect. This is messed up. Hello? Wait a second. Hello? Can you hear me? Oh, I can. Oh man, I can control your computer. It's now good. Jesus. I hate TeamViewer for this reason, but it's so good at the same time. Well, Kyle, if you're hearing me, please turn on your microphone.
Oh, sorry, I'm back now.
It's alright. TeamViewer just got mad.
Yeah, sorry. When TeamViewer started up again, it started with the mic muted by default.
Yeah. So what we haven't heard?
Yeah, I was just kind of saying this VR thing. It's just early sort of prototype stage now, but I would love like down the track to see it as like a multi-user patching environment in virtual reality. Yeah, the consumer version of Oculus will kind of they'll have some hand controllers. I think not exactly like this, but the same sort of thing where you have this sort of 6 degree of freedom.
Oh, really? They will have.
I've played a bit with Leap as well. I find it kind of fun for fun things. It's a little bit difficult, in my opinion, if you want to do something a little bit more precise. Like, I guess the software will get better for it, but for me, the Leap interface of it works most of the time, but it's frustrating when it's only most of the time.
I don't know. To be honest, I never had a problem like that with Leap motion. I mean, it's like a very good sensor with a very good SDK now. Like the 2.0 about the SDK, the second SDK, the skeletal tracking, it's now a good SDK. It was with the previous one, it was a little bit of disappointment, but now with the newer SDKs, it's amazing what you can do. I mean.
Oh, cool. Well, I'll take a look when I get home again. Did you ever add headset support to the plugin pack you've got for it?
Yes, I've added because I needed once. We needed to make a Oculus demo, and I've added the head-mounted display mode, which is surprising, but it works even better. So the best best results.
Oh, cool.
The best results what you can get with leap motion if you strap it to your forehead, because that will.
Oh, look! I'll definitely try that when I get home. That sounds cool. Yeah, I mean, there's some advantages still to having like all these buttons and things, of course. But like for anyone that hasn't tried it, if you get a chance to try Leap in VR, I really suggest it. It's just fucking awesome. Because it's so like intuitive, you know. You're using your own hands. It's really amazing.
Yeah, indeed. But obviously with controllers, it's very much more defined behaviors with the buttons, and I see that the Hydra controllers. It's such a shame that Razer was bad. Razer didn't continue that product. It's just I don't understand why it wasn't that much success. Because it had I think their problem was the wires.
They're good controllers.
I think their problem was the wires, maybe. They couldn't have gelled it. But, I mean, yeah, gamers were complaining about the wires, and they were like, "Oh, so this is wires, this is shit." But you know, come on, it's such a first world problem for a controller. What you have. You get 2 times 6 degrees of freedom, 12 fucking degrees of freedom, even more because only
actually even the triggers, it has a trigger with a like a slider value as well.
Yeah, and so you have you have 16 degrees of freedom because of the triggers analog as well. The triggers are analog. I can't remember now.
Yeah.
So do you have? You've got
like a button trigger and an analog trigger both.
I see. Sorry. You have not just. You have 20 fucking degrees of freedom. 20.
More degrees of freedom than you can poke a controller at.
Yes, indeed. I don't know. I don't know that they kind of started to do these prototypes. Yeah, it was ahead of its time. Yeah. But for now, it would be kick-ass. If the Oculus controllers will have the same kind of fidelity, that will be super awesome. If the Oculus controllers would give us the absolute position and also suggest, that would be absolutely amazing.
Well, that's kind of what I'm hoping for. I'd be a little bit surprised if they didn't, but I will see. Yeah.
Yeah. I think that might covers it. So we switch back to the intro. Thanks for the amazing workshop, Kyle.
No worries. Thank you anyone who wanted to spend their Saturday night listening to me hungover and rambling.
Yeah, Saturday late night steaming hot Instance Noodles workshop. Yeah. So I wanted to don't go away yet, just because just for you. I mean, I was telling this to Kyle. I was telling this to Kyle. So I have a couple of announcements to have, and that is I set up a Patreon account, which is very basic for this, but I will launch it in this exact moment. I click that launch button, I don't know what will happen. And it is live. So anyone who wants to throw money at the weekend workshop thingy, it is very, very welcome to do. The lowest, I chose the monthly payment thingy because that's kind of makes the most sense in a program like that. Yeah, any comments on those? The rewards, I don't know if the rewards are valid or not, but they are also, I don't know. So yeah, if you have any suggestions on that, I'm very, very open to that sort of stuff as well.
The joy of giving is its own reward as well. Like you'll get a warm, fuzzy feeling.
Yeah,
it's really great of David to organise these. So yeah, I hope you get a bit of love there.
Yeah, you might, you want something personal out of this thing. And also the second announcement is the next workshop will be about MSHA. So for example, what you can see now, you will be able to do that, I hope, by the end of that workshop. And that will be because the next weekend is on Christmas. Obviously I won't do that, so I will do that actually, holy Jesus, 3 days later, ladies and gentlemen. So on 23rd of December, and then after Christmas we will have a special edition. I won't spoil you currently who will be, that will be an interesting topic as well. And what else? Yeah, so I hope I see you guys on Wednesday, actually, the weekend workshop on Wednesday, so I can have a proper Christmas as well. Yeah, so thank you guys for watching. Thank you for your comments. And see you before Christmas. Bye guys, I've stopped streaming and then I will stop recording.
Take care. Ciao.